Well, I got all the caps done except for this one here, which is this one up here. I have to move the camera so you can see it, which is the one that's not on the schematic. And I'm about to check voltages. Currently have the voltmeter across the B plus. Give you an idea how much voltage comes into these radios. Set at 117 volts. So we'll see what kind of voltages we get on these tubes. So let me turn it on. I'm also doing one other test before I disconnect the antenna, and that is I changed two capacitors. I changed the one in there up on the top that I hadn't put on, and the one on the top of the tuner. So let's check that one more time, and then we'll go. Okay, so the B plus is up to 387, and now it'll start dropping as the tubes conduct. And let's see where it bottoms out at. Okay, let me get this off the station. We know that the radio's playing. Okay. All right, so the B plus is 325 is where it settled at, and that's not bad. We'll go ahead and disconnect that. And we start checking voltages. Before I can do that, I got to, excuse me, I got to disconnect the antenna, which I just have basically in there. I have to move the, got it, okay. All right, so B plus is fine. Now we're going to check the voltages, and let me see if I can bring this, my voltage stabilized at 116.3. Let's see if we can get closer to 117. There we go. 116.9. Good enough. Okay, 117 volts on the input. Now, we'll check voltages. And we will start with, let's see, here's our bottom view of the tubes that I made. So let's start with the bottom right here, 6J5. And on the 6J5, we should have 130 volts on the plate, which is pin 3. So let me get the light down there where I can see. And it's a little hard to see the, I think that's it, yeah. It's hard to see the key down there. I'm assuming that's the key. We'll count them and try it. 1, 2, 3. It looks like that's ground, so that can't be the key. I see it. 1, 2, 3. Okay, here's the plate. And we're at 64 volts. That can't be right. 64 volts, let's see. That should be a 6J5. Well, that's not good. That's the oscillator. It should be 130. So we're going to have to find out what's going on there. Let me get that light in there again. 1, 2, 3. Yeah, that's the plate. How to make a contact on it. 64 volts. Wow. That's half what it should be. We'll have to find out. It's probably a bad resistor there, open resistor or something. Let's try the 6L7 on the converter. Oh, wait a minute. Yeah, let's try the converter. 6L7 on pin 3 should have 240. So this is 6L7 here. 1, 2, 3 is here. We got 286. So I'm thinking there's a resistor issue going from that tube to the 6J5, but we'll figure that one out. All right, so we're getting 286. And we should have 240. And it should be within plus or minus 20%. So it's fine. Well, yeah, 40 volts. It's a little bit high. It shouldn't be over 280. It's 286. So we'll have to figure that out. Again, remember, this is not the right transformer. This is a replacement transformer, so these voltages may be a little whacked. Let's try the 6K7 right here. Now, there's two 6K7s. This one should be the... yeah, this one should be the IF, but I'm not sure. We'll have to check. Pin 3 should be 237 on the plate. And that would be 1, 2, 3 straight up. That's high. Okay, and the screen, let's see what the screen has, pin 4. That's not the screen on that pin. Okay, hold on. 6K7. They both should have 80 volts on pin 4. 240 up here on the plate. And we get 280. And on pin 4, it's hard to get on there. Okay, we got 97. We should have 40. Let's check on later this on pin 4, the 6L7. 286. That's pin 3. Pin 4. 97. So we should have 80. So we're high on the voltages. This transformer is putting out more voltage than it should, which means I need to drop it down because mains is higher than 117 volts. So we don't want the voltage that high. Let's see, next, the 5x4 rectifier should be 298 volts on pins 7 and 8, and we know we're getting 300 and something on it, but let's check it anyway. 7 and 8 are tied together. 7. Yeah, 328. And 8, we're going to have the same. Yeah. Okay, so there's our problem. We should have 298. We got 328, and that's kicking up the other voltages. Of course, some of these resistances out of tolerance. All right, let's move on up. And the next two tubes we'll do is the 6H6 and the 6K7. So let me adjust the camera here. Bear with me when I turn it up. And that's the bottom two there. Probably not going to see. If I put it there, you'll be able to see the meter. Okay, so the 6H6. The 6H6 should have, um, well, it's a second detector, so it should have -2 on pins 3, 4, and 5. Actually, -2.5 on 3 and 5, and -2 on 4. So, yeah, that's the 6H6, which is this one here. 3, 4, and 5. We have -3, that's fine. -2.7, -3. Okay, they're not bad. They're a little high, but they're not bad. Again, all the voltages are high. And now we'll check the other 6K7, which is this one here. And we should have either 237 or 240. It doesn't matter on the plate on pin 3. So we'll put some light up there. And pin 1, 2, 3 is here. My meter's about to go off. Let me reset it. Okay. 1, 2, 3 right here. We got 280. Well, that's high. It should be either 240 or 237, depending on which 6K6 it is. And on pin 4, we should have 80. We're probably going to have 96 again. 1, 2, 3, 4, 90 something. '97, yeah. All right. Now we'll do the top two, which I need to lift this up a little more. You won't see the meter. You just have to take my word for it. But that's this one up here, above that, and that one up there. And we'll do the 6H5 first. Excuse me, 6H6. And, oh wait, we did that. I'm reading it wrong. My paper got wet, so it's hard to read. Oh, it's the 6H5. Hmm. 6H5. Why do we have a 6H5 up there? So we got two 6H5s? I must have wrote that wrong. 6H5. Oh, 6F5. Yeah, that would make more sense. I wrote it wrong. 6F5. Okay, that's the first audio. We ought to have 82 on pin 4. 1, 2, 3, 4. That's this one here. 82, and we got jumping around 172. Wow, that's high. That don't make sense. Whoa, that's way up there. Okay, something seriously wrong there. We'll have to figure that one out. And then the output amp. That's the 6F6. 6F6, we should have 225 on the plate and 240 on the screen. It's a little bit harder to get to. 1, 2, 3 is there. We got 277 on the plate. And I don't even know if I can get to the screen. Right there. 285 on the screen, so that's not too terribly bad. It is high. They're all high, but the 6H5 has got a serious problem. 1, 2, 3, 4. 173 volts. Why would that be so friggin' high? Oh, that's coming across that 220 k ohm resistor that I'm going to put in. 172 volts. And here, that's ground. So we got 172 volts. Okay, let's take a look at that on the schematic. I'm going to remove the phone. Actually, before I do, I want to cut this capacitor out of circuit here. Because that shouldn't even be there. Let's see what that did to the signal. Not a down, we want to turn. Well, that definitely does help. But it's not on the schematic. I don't know why they put that there. Of course, I don't have the antenna. If I put the antenna on, we're going to go way up in volume. Okay. So I don't know that we need it, but all right. Okay, let's see. Let's shut it off. So we do have a problem with the voltages being high, and especially on that. I'm going to take the camera loose here. And we're going to look at that tube, which is the 6K7 on the schematic, and see why we're getting so much voltage on that pin. And here it is, by the way, 6K7. Oh, wait a minute. Let's see, 6F5. That can't be right, but it's a 6A5. It should have 82 volts, and we're getting 171. Really strange. First audio. So that's this one here. And on the plate here, we're getting 171 volts. Why would we be getting 171 volts on that plate? It gets its B plus from this switch, I believe. Hold on, let's see where that goes. Down here. No, that's low voltage there. So it gets its B plus here from this chain, and from that should be what? That switch, which connects to this line here. So from here to here, well, this is the cathode. So yeah, it's getting its B plus here and through here. No, that's AC. Part of it from there, but that's on the other side. And let's see that screen grid. Screen grid. What's the screen grid on the output tube? 6F6, 240. So, and we're high, but that's 240 here. Coming down here. To this side of that, the field coil. It's right off the field coil. So 240 there. Yeah, that's where it's getting its B pluses through these two resistors, R11 and R12. 220 and a 180. That's a voltage divider there. All those capacitors have been changed, so they can't be shorted. It is amplifying fine, but boy, it's getting a lot of... Let me pull up the specs on that 6F5. Okay. Pin 4. Yeah, pin 4 is the plate. 3's not used. So it's just a basic triode. It's just a basic triode amplifier. Maximum plate voltage is 300. So 170 is not a problem, but why is it so high? 0.3 amps heater current, but that's the whole heater string, and I know that's fine. I don't know why that voltage is so high on the plate, unless this is a mistake, because that seems awfully low. That would be rated 82 volts here on the plate, and those resistors. Here's the plate. It's going through a 220 and 100K right to the speaker coil, right to the B plus line. So here, which is the opposite side of the 11 megs. So it should be going through both 11 megs to get to R12. So let's find out if we're going through both of those. We should be. 12 is the 180K, so it's a 180K is that one up there. I'm sure there's still charges on these capacitors, but there's the 180K back here. Both capacitors should be in line. I mean, both power resistors should be in line with that. So they're connecting, and they are, because it comes from here, from the 8 microfarad capacitor. From the positive of the 8 microfarad capacitor is going to there, which is feeding the plate of the output tube, and that voltage is fine. Then it's going through both of those resistors and coming up to the plate of the 6F5. Unless I'm looking at the... No, that has to be the right one. Yeah, because that one's going... Yeah, that's going over that way. So that ain't it. Let's go into the output tube. Yeah, it's coming from the plate around the top here down to this end of the 22K I think that's supposed to connect pin 4 to the outside of the 22K. Let's check that again. Pin 4 to pin 11, which should be the 22K. There, the 22K. There it is. So it goes to the 22K side of this voltage divider. And it's blocked here by this C14, so it doesn't get to the grid. Actually, nothing gets to the grid but AC, because you got, well, wait a second, I take that back. The cathode voltage comes through here through a resistor. And I believe that cathode is ground. So this side of the resistor is ground. No, that can't be. Hold on. Yeah, that's ground. So the cathode, the grid is just above ground or just negative on the 6F5. It's not showing that, I don't think. 6F5. Pin 7, 6.2, that's the heater. Yeah, it's just negative, just a little negative. And that would make sense. So that would put this tube conducting. The grid is just a little negative in comparison to the cathode. And then the only signal getting through it is from the volume control through this capacitor and some automatic volume control feedback through here. Any signal is being routed back through the tube. So that is correct. C12, let's see what C12 is. That shouldn't have any effect on the DC side. These connect together. So that's got a capacitor in line. That ain't doing nothing but feedback too. That's on the switch for distance local. And all that does is provide feedback to the cathode here in the pressure grid. So here's the bias issue that's causing the problem, but I don't see any problem. The values are correct. That plate connects to the 22K, which connects to the 180K and goes to be positive. There's no reason for that voltage to be 170 something and the tube voltages to say that that's supposed to be 80 volts. We're not in any danger because the tube can handle up to 300 volts on the plate. I mean, again, it's high, 170 is high, but all of the voltages are high. I'm going to need to drop this voltage down. Apparently this transformer is not the same as what was in there. It has the same supplies, but the voltage is higher. I'm going to go ahead and check the rest of these resistors and see if we find any that are open or shorted. A shorted resistor would drive the voltage up. An open resistor could do it if it's taking, if the voltage is supposed to go to another part of the circuit and a load, and it's not being loaded down. But more likely an open resistor would do that. That one there is very suspicious, but when I checked it, it didn't check bad. So I'm going to go ahead and put the camera back and check some resistors. Okay, so shut the power off. Okay, the power's off. Capacitors will have to discharge a little, but that shouldn't take long. Let's just turn the radio on, let it pull some of that power out of those capacitors. And we'll check across them. Let's see if we have any voltage left across this B plus. Nope, not there. And here. No. Okay, so it's discharged. So now we'll shut it off and check some resistances. For that I don't need my probe cover. Don't want probes at all. You get false readings with probes when you're checking resistors. It's better just to jump across them with alligator clips. Get a nice good contact. Okay, this is a brown, black, orange, so 100K. Like circle K, it's on the way. Sorry, 10K, brown, black, orange, 10K. So we got 13. So it's a little bit out of tolerance, but not bad. It's good up to 12K, so yeah, I can replace it, but that's not the problem. If anything, that would be dragging the voltage down, not up. I'm thinking it's a transformer. Let's try this one here. It should be a 22K. And we're getting 23, so that's fine. That resistor is perfectly fine. Let's try across this one. It's a brown, black, red, so it should be a 1K. If I can get on it. Out of the way. And it's perfectly fine. There's nothing wrong with that resistor. This one could be changed. It's not really a problem. In that circuit, it don't really make a problem. And this one is 22K, and it's supposed to be 15K. So it's really bad. I'll go ahead and change that out. It looks like it got hot. See the paint flaking off of it there? So it's gotten hot. It could be flaky and causing a problem. Let's check these that I put in. This should be a 220. 221, perfect. And this is a 180. Oh, there we go, 180K. I just wasn't making good contact. I don't know why. Let me check that again. Why am I not getting a signal there? What's going on with that resistor? That would do it. That would drive the voltage up if that wasn't making contact. That's our B plus line there. I check those again. I keep getting on the insulation. These wires have something weird there. Something weird there. It was very hard to get in there and solder. These wires have two sets of insulation on them. They have an outer cloth, and then they have a wrapped cloth. Yeah, that one's not making oh, wait a minute. Yes, it is. It was charging the capacitor back up. And let's try this one. Yeah, because that's megs. Okay, it's yeah, but it shouldn't be megs. Well, that's weird. Why would it read meg ohms when it's 178 ohms? Let's strange. Why was I getting megoms across that? Right there. It should never be megoms if I've got if I'm going across a maybe this one ain't making contact. I'm going across a 180 ohm resistor. It should only be 180 ohms minimum, maximum. Yeah, see, I'm not getting no signal there. Something's whacked there. What is the problem? That was a very hard area to get my soldering gun in there. I may have to undo that and redo it. That resistor's obviously not making contact. Very good contact. Let's try it again. Okay. Come on, get on there. No, that's fine. That's good that time. That's not. That should not be doing that. Open load. It can't be an open load. There's something wrong. Intermittent. Where's that wire go? Goes over to there. See if I grab it on this end. Could be, like I said, they got 2 layers of insulation. Yeah, see, it's fine. It could be that it's got like some residue on the wire and I'm getting a false reading from the residue. Yeah, it seems fine. It's not doing it now. So that was the problem. You got to be careful. But anyway, yeah, you got to be careful. Sometimes there'll be a residue on the wire, and you touch on it, and you get these ridiculous readings. But what it is just not making contact. Even though you're looking at a nice clean wire, and you think, well, that should be clean. And the other thing is, if there's resin on the wire and you solder it, you could have a bad solder joint, but that solder joint's fine. And see, it's doing it again. Right? It's only when I pinch on the wire that happens, and now it's open load. Well, where's that wire going? Wire is going here. That is open load on that wire. And the other wire is okay then. No. What the heck? Solder joint's fine. Get on that. No, it ain't. Something's wrong there. Oh, it fell off. Yeah, something's wrong there. That resistor is like faulty. It's not making good contact. I'll have to unsolder that. Actually, what I'll do is cut that resistor out, put another one. I can cut it out on this side. I like to put the resistor leads through the eye loop of the connector, but there was really no room there to get to that. You know what? Maybe I could. That looks like the lead there. Maybe I could just heat that up and reflow the solder. Let me clean my tip here. Let's see if we can reflow that. I know the resistor is not bad. It's a brand new resistor. It's very tight in there. See if we can pull it out of there. This wire out of here. Clean that up. I also want to get them out of the way. All the wires from the old electrolytic. They're just in the way of me getting my soldering gun in there. Don't need them. I can get a pencil soldering gun in there, but it ain't gonna do any good. I need the heat. I've got too many wires together. I need the wattage. Yeah, that should be fine. Let's try soldering it again. They look pretty good there. Let's bring that, clean this up. I got way too much wire there anyway. Take some of that off. I hate having to come in from the front like that, but there's just so many wires in that one lead. But this is a brand new wire, so it will flow up the wire anyway. Let me flux it. Okay. We'll try it again. Okay, that's much better. Cool it down. Get the flux off there so I can see it. That looks better. That looks better. Where's that resistor? Move aside. Yeah, he's solid. Alright, let's see if we have that intermittent junk now. Nope. And here. Nope. We're fine. Back there. Yeah. There it is. So that is something on the wire, because you notice when it does finally make good contact, the resistance is where it belongs. If the resistance was low and slowly climbing up to 178, I'd say, okay, that's fine, because that would be a capacitor that's charging up. And as the resistance of the capacitor comes up, it would stop at 178. But to be higher than 178, and coming down is impossible because the resistance 178. It's going to take, electricity takes a path of least resistance, and 178 is a whole lot less than a couple megs. So what's happening, and you can probably see, I don't know, there's like some kind of residue on the wire. I'm not concerned with the residue on the wire not making contact when I clip on it. What I am concerned with is at the end of the wire, that residue didn't get burnt off so that the solder could stick to it. Because if there's no connection, then there's a bigger issue. Now there is. So now if I come down here, I should have my 178, which I wasn't getting before. And there you go, there it is. So we fixed the problem there, and let's see if that helped us with the voltage on that tube. I'll put this back on ground. Put this back on the plate of the first audio here. And the unit's off. I turn my power back on. Put this back on DC voltage. Bring the voltage back up to 117. I don't need to get exact. But I'll get close. Okay. 116.3. Turn it on. 352. It should start dropping. Still too high. So that wasn't the issue. For some reason, I'm getting full B plus on that. Well, almost full B plus. I'm thinking they probably made a mistake, because you see how that stopped at 180? It's now 179, 180, and they're saying 80 on the schematic, and that really just does not make sense to me. 180 makes sense. Yeah, 180 makes sense. 80 does not make sense. 82. Why 82 though? That just doesn't seem right. It just doesn't seem right. The consumption is 75 watts. The power output is 4.5 watts. I'm getting for wattage 66. So we're using less watts than it's supposed to use. Why are we having so much voltage on that pin? That's coming from the 22 volts side of the capacitor. So the meter is loading it down too. That's weird. That's weird. Get out of here. Let's put that back on. 176 volts. So that's what we're getting here is 172 volts. 175. That wire has 3 voltage drop across the wire. That's weird. And here, 234. 286. So 286, 234. Yeah. Okay. Here's what we got. Okay. So we're saying it should be 82. We got 286 here, which is the B plus. 286 here. We got roughly 235, 238 here, and we got 170 something here, which would make sense because we're dropping the voltage roughly in half. Half of our voltage drop is from here to here and here to here. I mean, they're so close in value, these two, R11 and R12, that all that does is drops the voltage across this capacitor, which goes to ground. So C14, across C14, we're having a lot of voltage. That's a 0.2 microfarad to ground, coming off the center of those. And I have a 0.223J coming off, no, I'm sorry, right here, 0.224, which is a 0.2, going to ground. And yeah, it's on the ground. Connecting between the two resistors. I have that in the right place. There's no way that tube could be shorted. Okay, I'm across the rectifier, and I'm going to bring that voltage back down to where it's supposed to be and see what happens. We should have on the rectifier 298 volts on pin 7 and 8. I'm across pin, one of the pins. 298 volts. Okay, so I went down a little bit low. We bring it back up. All right, 298 volts. That's at 105 volts of mains. So that shows how far off that transformer is on the rectifier. Okay, now we will check some more voltages again and see what happens. Well, I replaced this resistor that obviously got too hot and is way out of tolerance. I didn't have any, well, I probably could have put a 1 watt in there, but I didn't have any 2 watt 15K. So, and this is a 1 watt, but I didn't want to put a 1 watt in there, and I would have probably still had to use 2 resistors for 15K is an unusual denomination for modern day resistors, so I put in a 10 and a 4.7, which give me close enough to 15. I'm within the 20% tolerance, well within the 20% tolerance. Anything over 13K would be fine, up to 18K. And since that was going to, I don't know about this. This is something I'm not sure about. I had trouble with that when I put it on. It kind of didn't make sense to me. That was the wire that was loose, but by the schematic it looks like it went there. So I don't know. But what I do know is that also goes down here to this resistor, jumps across this resistor, and comes down to this wire here, down to that resistor back there, jumps across that resistor, and comes down to here, to the pin 3 here of this 6J5, which was only 40 volts and supposed to be 80. It's the only one that was low. So I figured that resistor was too high, so it was cutting voltage down. Don't know that it was cutting it down that much, but it was cutting it down. And I don't know if that's causing another issue, but I don't think so. That is on, this one here is on pin, look at the light in there. 1, 2, 3, 4. It's on a screen grid of the 6K7, and it's going to the 15K. So if I come up here on the screen grid of the 6K7, comes down here, and it goes to R10, which is R10, which is the 15K that I just replaced. So it does go to that resistor, and it goes to the side of that resistor here. Where is it again? It goes to the side of on the field coil side. Wait a minute. No, it doesn't go to that resistor. Well, there's my problem. I goofed. So that comes off the screen grid, which also connects to the screen grid of the other 6K7. Yeah. Ah, that's wrong. That's supposed to go, that looks like a connection, and it's not. It goes to the 8 microfarad capacitor. Goes to C20, 6 microfarad. Okay, I found I got those two resistors in, which brought the voltage up here to 190, where it was 95 before. Get that out of my way. So I'll shorten on with it. And that took care of the problem down here where I was only getting 60 volts. In 3, 1, 2, 3, right here. I was only getting 60 volts. Supposed to have 130. I got 122. Now I'm only at 96 volts. So that should fix stuff, but I'm still getting too high of a voltage here, which I think is just an error on the schematic, because I'm getting 165 there. It won't hurt that tube, because that tube can handle up to 300 volts. And let's see what we're getting for our input voltage here, mains voltage. Okay, I'm at 278, supposed to be 298, but I'm only at 96 volts. I think it was 101 was giving me, let's see, all right, let's try 100. I think 100 or 101 was giving me the 98 voltage I needed, 298, yeah, 288, okay. So about 101, I believe. Let's try that, 102. 102.4 just jumped up. Hard to get in there. All right, that's better. 295 volts. Okay, so that's not bad. The pilot light is good. Let's see what happens now with the radio. I still don't have the antenna connected. Let me go ahead and put that on there. I just lost my capacitor. Hold on, I'm going to pause this and find that. Okay, I keep a capacitor on my outside antenna just for safety. So let's see, we're on local. Let's get back to my local station here. Okay, not getting nothing. Why not? Is that guy? Why am I not getting nothing now? Oh, the antenna come off. That didn't help. All right, let me put a clip on that. It's just easier to clip it on than it is to try to get it to stay on that screw. Well, I say that, but apparently not. Okay. Now, all right, let's see if I can tune it in now. I'm amazed at how nice this radio sounds. It's just amazing. Anyway, so it's playing fine at 102 volts. So I do need to bring the voltage down on that transformer. That's obviously a problem. And that tube I don't think is an issue. You hear how quiet it is when it's between stations? Okay, it's on a station now. Now watch when I get it off the station. Look how quiet that amp is. That's full volume. That's it. Amazing. Now, I haven't done an IF tune. I'm sure it'll come alive when I do an IF tuning, and there'll be a lot more static. And I'm going to do that now. That's the next thing, is to tune the IF. So I'm going to set up for that, and we'll tune the IF at a low voltage where it should be. And then I'll figure out how to get what resistance or capacitor or whatever I need to get the voltage down to that level, because I don't want it that high. So that's where I'm at. Give me a second to set up, and we'll do an alignment, see if we can get more stations. Okay, we're connected to the first detector and ready to do our alignment here. Okay, that's pretty good. That came up. All right, let's turn that down a little. Okay. Oh, we're getting some static. That's a good sound. All right, that's that. Now, let's see, we do the low end of the dial. They want a 200 microfarad and set the oscillator at 1500 and the dial at 1500. Okay, let me get the dial up to 1500 and we'll do that one. Hold on. Okay, I got the oscillator peaked right about there. 1500. So we're good to go there. And I think it's okay. I'm going to go back to the 600 and check that and just make sure that the dial's okay, and we're done. Okay, so the next thing we're doing is we're on the antenna with the 200 microfarad capacitor. And we're doing the 1500. So we want to set the oscillator, which is F, for maximum. And F is this guy here, which is this guy right here. Okay, that's it, that one. Then we want to do G and H to align the antenna and the detector. G is here, these two, G and H, which is these two. Okay, not the best we're going to get there. Getting a little bit of noise out of that. Okay, I went ahead and got a plastic stick, but unfortunately I have to use two hands to turn these. It's just picking up noise. Well, let me turn that back up a little. Okay, try again. Turn the volume up. Oh, wrong way. Okay. I think I got them about the best. Yeah, that's about the best they're gonna go. All right, the next thing we need to do is J at 600, and J is right there. So he is that one down there. So let me get back down to 600 and we'll do that. Okay. And I'm doing this one here. Right there. Okay. Wait. Okay. But I did find a few cool things on this. The next things I got to do, well, one, I got to put a resistor and drop the voltage down. Running at 103 now, and that's about where it should be. So this transformer is putting out way too much voltage. So I got to drop it down somehow, but I'll deal with that. But I found some cool things that I thought you guys might like. Probably noticed it already. Look at that dial and tell me if you notice something different. Anything different? I'll give you a clue. Where's the AM? gone. Look at this. Ain't that cool? Look at how that comes in. That is just unbelievable. There's the AM dial, there's the shortwave dial. A couple cool things I found. One, of course, is this shortwave dial. That's what was copyrighted in 1937. So I figured the radio would probably be 38, 39, but as early as 37. However, I found out that's not true. I didn't do any cleaning, but I did a little dusting so I could read these cans to know what they said about the frequency of 456. And I noticed these. December 7th, 1943. Look at that. December 7th, 1943. That is 2 years to the day that the Japanese bombed Pearl Harbor. In fact, not only is it exactly 2 years to the day, it's 2 years, it's the exact day that the Navy released its first official video of the bombing of Pearl Harbor. They released it on the 2-year anniversary of Pearl Harbor, which was December 7th, 1943. I thought that was really cool. This is an awesome radio part of history because it's actually the day that they were the anniversary of Pearl Harbor to 2 days, and it's the day that they released an official first hour-and-a-half video, which you can watch on YouTube. Let's see if I can pull it up here and show you. I thought it was really cool. If you just search for the date, December 7th, 1943. And here it is. There's the original one. The Department of War, Navy released by the National Archives and Records Administration, December 7th, 1943, the same date that's on these IF cans. That was the official release of the information that happened 2 years prior on the attack of Pearl Harbor. And there it is, John Ford's December 7th, 1943 Pearl Harbor attack. It's an actual video that came out, propaganda video produced by the U.S. Navy on the 2nd anniversary of Pearl Harbor. And that's the exact same date as what's on these IF cans in this radio. I thought that was really cool. So there's some historical significance in this radio, and that's pretty cool. So anyway, there's the radio and it working, and I got to clean it up now. I'm going to go ahead and clean that up. I have to drop the voltage on that power transformer. I have to figure out if we can find some, I don't know, we need some belts to drive the tuning mechanism, because you can't even tune it without those belts. And also need to get in there and clean all that out and oil it, which will help some, oil those gears. But this isn't doing anything, just fine tuning, because this would, normally this connects to the same thing the motor connects to. So the belt, this would be turning it by hand and it would go kind of slow. And it's a long way around, right? So then you would use this, which turns the motor on and would move it for you, so you didn't have to move it till you get where you want. But both of them use the belt that's gone. So we need the belt. We need the belt for the motor and the tuning, and we need the belt for the tuning for this one. And then this is the volume. This is off, local, and distance, which does amplify a little bit for distance stations. I should have put it there while I was turning this. It's just so hard to turn it without that belt. But anyway, it'll get stations. Let's see, there's some distant one there. It'll get stations. I did notice that this disc is cracked. I'm going to try to at least line it up. I don't know if there's anything I can do about that. It's just age. But you don't see that inside the box anyway, so it don't matter. The part that I don't like doing, and I'll do it for the customer, but I am very leery of it, is taking this glass off. This is a domed glass, and the rubber supports are totally gone on it. So I'm really worried about taking that off to dust inside there and clean that. If I don't take the glass off, I can't clean it. If I take the glass off and crack it, I am really in trouble. So I don't know. It's a catch-22. I may have to tell the owner that if they want me to do that, I'm not going to be liable for that dial. If they want to do it, then they can do it themselves, because that's... I just don't feel comfortable pulling that glass off, but it's so much dust in there. It would be good to clean it. If I had a replacement glass, I wouldn't be so worried about it, but there's no way to get one. And then up here, you got foreign, base, high fidelity, normal, and voice. Okay, so that's a little bit out of kilter there. Foreign, base, high fidelity, normal, and voice. That's me reaching around trying to tune it. And what I've been doing to tune it is turn these gears here. And they're hard to turn by hand. I mean, you know, this belt drives that gear, which turns it, but it turns it really slow. I mean, you'd be there forever. Going down is fine. Going up, it just slips. See, it doesn't want to go up. So once you're on the low end of the dial, that's not working good. And that needs to be cleaned, and we need to find out why that's not wanting to go up. I need to take this out of the way, and all I can do is, I can't take it completely out because it's riveted to the bracket there. These cans are here. So the only way to get in there to clean it is to blow it out. I can use some Q-tips on the chassis, but blow it out, and I can get oil in there. We got to figure out how to get the band on that. Yeah, if I close the dial, put it all the way down, I might be able to get by the capacitor. I think that's going to be the key. Get that all the way down, and then, yeah, I can slip the belt over it, because I sure don't want to take that off. Yep, that'll work. That'll work. So we'll close the gang all the way, the condenser, and slide the belt up through here and just put it over the wheel, and then put it on the bottom. But anyway, that all needs to be oiled. There's some wear there. If you look at those teeth, see that black spot there? That's where there's some wear that's making it slip. I'm hoping just cleaning that, maybe with a needle in between the teeth, get the dirt out of there, and then oil it. We'll do it. I need to change the bulb. I got some new bulbs. This is a temporary old stock bulb I put in here. 44. I got a brand new 44 I'm going to put in here. I'll do that now. So I wanted to get the video to this point where it's playing and the owner can see it working and it's recapped and the IF is tuned for AM, and that's fine. The shortwave, it's okay. It'll work. It'll get some stations, but there ain't going to be any stations much to get anyway. So, and he's not worried about that, I believe. He wants Bluetooth on this. So that's another thing I got to do is add Bluetooth. But I want to get the voltages right first. Then I got to put a jack on it in the back or in the cabinet and a Bluetooth unit. So a lot of time, a lot of labor going into this unit. It had a lot of issues, and I've been dealing with them one by one, but there's still a lot more to go. So, you know, time is money. But, you know, I just want to make sure it's in good shape when he gets it back, and that everything that I can get working is working. The biggest negative is the belts. I don't know what to do about those. I don't know where to get them, and I don't know if I can have somebody manufacture them. I doubt that the ones we got can be repaired. They're no good. Excuse me, they're dried out. They're only good for, you know, getting measurements off of, but they're not going to work. Maybe a rubber belt, like for a, well, I don't even know. Maybe a belt like they would use on an old VCR. Those are usually flat belts, and they're kind of long, but I need to get the right length. So that's the next thing I got to work on, is that after I finish getting the voltages down off that transformer, because it's just putting out way too much volts for this radio. That's not the right transformer. I also need to tighten it down. It's loose, but it's not bad. I mean, it's fine actually, but because I can't really put another, there's no way to bolt it anymore on this side. It's only got 2 screws going through, and the other side doesn't have any bracket. So what I'm going to do is maybe, I don't know, maybe wedge something under it or something, but if I can get it from, it's probably fine. I just need to get the voltage down on it. So that's where I'm at, but I'm going to upload this video, and then later I'll do a part 4, but it's just going to be a finished video, which will show you the unit with the belts in it, and then, you know, and the power being right, and then in the case as a final demo. But right now, the main part of the work is done, other than, you know, these odds and ends that have to be addressed. So I appreciate you watching the video. I hope you found it interesting. I really hope you found that dial interesting. I think that's amazing. And that's also on the U.S. patent. That's what's patented, is the dial itself in 1937. And then we found those cool dates on the IF cans, which I think is a neat part of Americana. It's added to this radio. Great provenance. So, you know, people were listening to this radio when they bought it new, listening to World War II and the outcome of the war. We were halfway through the war at this point. So it's amazing. I'm sure everybody was listening to the radios at that time, and this would have been the radio that these people would have been listening to it on. So great provenance. And thanks for watching, and please consider giving it a thumbs up. If you have any comments or questions or suggestions, please write them below in the comments. And thank you for watching. Have a great day.